Hi, everyone. So welcome to the conda-forge room.
And the packaging buff.
So in case anyone wants to look at stuff, I sent around. This is very biased packaging buff. I mean,
well,
we're not biased. We're
present.
Well,
I mean, it is a PIP support group as well. Like we feel for you.
Yes. I mean, and we have tooling to help with pip too, namely pip install conda. No, don't do that. Have you packaged the kernel? Well, there was a PR for System D. There were some issues with it, so we didn't accept it. But you could revive that.
Able to, I believe, in about November-ish, we'll likely be able to merge that PR.
I mean, we could have a Linux distro with Conda as packaging manager. Like if someone could just, write the kernel for us, please.
Yeah. Cool.
So, all right. So we've got enough hecklers now that we might be ready to start. Need to have critical heckler density.
Yeah.
Stop that too. I mean, Andy, you could also install, I think, Python 1.
Yeah.
Sure. Okay. So the BOF and conda-forge. So, hi everyone. So this is the packaging birds of a feather room. I'm CJ, and this is Marius.
Hi.
As our merchandising might show, we're both from conda-forge. And so I guess we're going to talk a little bit about the state of conda-forge currently. And then we're going to try to open up the floor. We're really interested in hearing about where people are interested in conda-forge going, what packaging issues they're facing, what pain points are they experiencing, especially for people who don't normally interact with us via kind of our standard GitHub, Gitter interaction points. Okay. So state of conda-forge, because I'm not really well qualified to talk about the state of pip, or at least no one wants to hear me talk about the state of pip. So conda-forge currently has over 10,000 GitHub repositories, which all build packages, or almost all build packages that are installable via the Conda package manager. Currently, since 2017, we've shipped 1.6 billion packages. In March alone, we shipped 120 million packages. We have a lot of infrastructure for automatically building packages via CI services, the majority of which are currently on Azure, but we also use Drone, Circle CI, Travis CI. I think we might even have one or two app layers left.
Yeah, I think there's something there, but not a lot.
Python might still build on AppFair.
Yeah.
We also have a lot of secondary tooling for keeping a lot of these packages up to date. These include bots for keeping versions up to date, keeping all of our packages well maintained in terms of the style guide that we have for all of our YAML files. So that's kind of where conda-forge is. There's a lot of work moving conda-forge forward, some of which is being done for moving us to optionally moving onto a new compiler stack, namely CentOS 7, which is required for some newer code bases. So we're working on that. We're currently building out SciPy support in addition to AR64 and PowerPC support. We've mostly finished the R 4.0 language rebuild, and we've mostly finished the Python 3.8 rebuild as well. So we're kind of getting geared up for Python 3.9. Some other things that we're working on. We also have a growing database of dependency audits. So we've gone through and read all of the meta YAMLs we have that describe the package, who the maintainers are, where to get the upstream code from, and most importantly, where the requirements are. And we've tried to rebuild that with a couple different tools, namely Depfinder and Grayskull. And so we're in the process of understanding all of the dependencies. Grayskull uses the PyPI metadata for those packages that have PyPI metadata to attempt to rebuild the meta YAMLs so we can check how accurate it is. So far, it's seemed pretty accurate. And Depfinder actually goes through and reads Python AST to determine what dependencies you have. And so if anyone's interested in kind of plumbing the depths of what conda-forge has in the way of Python packages and their dependencies, you're more than welcome to look at that. I'll go and post a link in the comment space. So let's see. That's that aspect. But yeah, I really want to open up the floor and try to hear what people want in the way of features or what issues they've been having.
So we do have a first question. You can see the questions at the bottom of your screen, and some of the. And I will read the question. The first question is what the difference between flexible and strict. My understanding is maybe it's a message about Conda doing the flexible solve and the strict solve, and maybe that's a Conda for more the Conda people than the conda-forge, because conda-forge is a package manager. And conda-forge is a package repository, and Conda is a solver which is made by Anaconda ENC. And so maybe you can enlighten us into those things.
Sure. So first of all, yes, strict versus not strict is a conda flag, and this describes how conda should go and do the solving among multiple channels. Okay, never mind. Let's take one of the conda one of the conda maintainers themselves. Come on down, Jonathan. Or attempt to come on down as we try to get you situated. While we're waiting on that question, I'll come to the next question because I think that one's a little bit quicker. Is Apple Silicon going to be a new Arch eventually? Yes, most likely. ACI provider needs to come along that provides that chipset. But yes, once someone's able to support that, we will start trying to rebuild it. Marius and I were just talking in the green room that actually some of our bots are well situated to do this now because of the training we've gotten with the AR64 rebuild.
Yeah. And some of the work that we're doing as part of the sort of like the CentOS 7 like global move is also going to likely make that a little easier on us. But yeah, like right now, nobody has, like, there aren't a lot of compilers out for it yet and things like that. So some details are still heavily up in the air, right? But we're definitely planning on continuing to support sort of Apple Macs.
Sorry, but back to the first question about strict and flexible.
Yeah. So when you conda install a package, you can install from multiple repositories, which are in conda world, we call them channels. And how does conda figure out which channel it should pull from? Should it, if you list 2 or 3 channels, which ones, and both of them have the same packages or similar packages, which one should get installed? So there's 3 different options. The first thing is that you can have channel priority. Basically, you say, if a package is available in a higher priority channel, I'm going to install from that. And that can have 2 different kind of sub flavors. The first is just the normal one, flexible. It says if the package is in a higher priority channel and it's consistent with everything else, even if I have to pull something from another channel, that's okay. Strict channel priority, on the other hand, says if a particular package exists in a higher priority channel, I will not consider any packages in lower priority channels with that same name. And so this is good if you want to definitely not get anything in lower priority channels, but it also means, say, if a certain channel only has certain versions of Python, like maybe SciPy, it only has Python 3.6 and 3.7, but no 3.8. And your lower priority channel does have a version of SciPy that is built for Python 3.8. With strict channel priority, you won't see that version, and you'll just get a conflict that you can't solve that environment. So those are the two basically channel priority options. The second option is just say, I don't care about priority at all. Dump all the packages into a bucket and choose the highest versions, the highest build numbers, everything, ignoring everything. So those are the three options.
Nice.
All right. So, is there a full stack package like Anaconda on just conda-forge packages? So So currently, no. Like in the sense of like the full Anaconda distribution, no. You can, of course, you can install the vast majority of those packages via conda-forge. We have most of those. But no, there isn't one. You could create a meta package that would do that and submit that to stage recipes. But I don't think anyone's put that up yet. I think there are some conda, things like mini conda that do use conda-forge packages alone. No.
Yeah. Yeah, in terms of sort of something as large as like Anaconda, generally we as conda-forge have decided to not like provide one of those sort of opinionated sets ourselves. There are some packages that like are big ones that contain like a lot of stuff. In general, we've been moving away from like a lot of these sort of big meta packages, mostly because the big meta package stuff tend to be under maintained. And so like they tend to point to old stuff. And that's typically not what you actually want. So we're generally in favor of saying, if you want to use a thing, just point to the name of the thing. So, but some of the stacks are like really big. Obviously, if you install anything that has like GDAL, you get an enormous conda environment that has like pretty much all of the geospatial stack already, just because it kind of has to have it.
Right.
Cool.
So Momma versus conda. What are the practical differences? All right. Differences, i.e. not speed, etc., but differences in the way solve happens. I think Wolf was here, and so is Jonathan, so...
Yeah.
I haven't looked at Momma's solver other than knowing that it uses libsolve, so I can't really talk about how they are different.
Okay. Wolf?
They use different solvers, and they produce mostly similar-ish outcomes these days. Is generally has been our observation. In fact, so some of our automated tooling does actually use Momma now to do some of our sort of like satisfiability checks for things like our automated bots, because it's fast enough that you can run it in the things. It's not going to necessarily be exactly the same. That is not the case, but like I think in general, if you find cases where the output of a Momma solve and a conda solve differ dramatically, I would strongly recommend you file that as an issue on Momma so that they can be aware of it.
Yeah.
Cool.
Okay. Handling of build numbers.
Yeah. Yeah, so there's a slight difference in like majorization of build numbers in Momma versus other things. Cool.
Any advice for deploying Python in a multi-user HPC estate with no container support? So I personally haven't been in the HPC region for a long time, so I'm going to demur on that question personally.
Yeah. Yeah, it's like in general.
I was doing it 2 months ago, so I can try to give some answer to that. As far as I've seen on smallish HPC system, you can make a global conda install and set the conda RC so that you can have global environment. And if users call conda, they actually get environments that are in their home. And that worked relatively well. As far as I can tell, for most people, you always have weirdish things. And when you have packages that do need to be rebuilt, you can provide your own channel that has been rebuilt, that only rebuilt on your architecture. But I think that's something which is really, especially with HPC, that are really idiosyncratic things where each HPC system have its own way of working. It is slightly different. There is not a single answer that you will be able to have. You have to go into the specificity of your system and talk with other people who have done that. So feel free to write to me and I will be happy to talk with you about that. But I think that's something where we do have to go deep into what you're doing so that we can get a right answer.
Yeah. And sort of some of us are also working on some sort of more like, there's a couple of people working on some tools to do sort of better conda environment management. A lot of those tools would likely have some use in like reproducibility cases in like HPC systems. So tools like conda lock and so forth, which I believe a lot of the people in the Pangeo space have started to adopt fairly heavily as a way of like reproducibly saying it's like solving my conda environment. Tell me what I built, and then remember that forever. And that so tools like that can probably help with some of the HPC setups for doing so particularly long-running reproducible science.
We also have started rebuilding packages on PowerPC for those HPC systems that are power-based.
Yeah. So it's like by now we have most of like the standard like numeric Python stack is there. Some of the bits are not because building Qt and things like that is super hard. So, but most of your standard stuff should be around these days.
Yeah.
And if there are particular packages in that you need for those compiler architectures, we're available on our Gitter, and you can sort of ping us. And we've got a fairly simple way that we can add one to that sort of evolving frontier of like package support that gets automatically pulled out.
And we'll link to that here.
Yeah.
Is there a path towards packaging the Julia ecosystem? Yes. I don't know if we know what that path is yet, but yes. My understanding, which is loose, so please take with a massive grain of salt, is that there were some potential issues with the way that Julia was patching various things.
Yeah.
That, as Wolf says, like, yeah, we definitely need to update Julia. There were some questions about patches that were going in and whether or not they would be compatible with the rest of the ecosystem. I think at one point, BLOS itself might have gotten patched. And so hammering on that would be kind of difficult, but certainly something that someone should do. Like the conda-forge ecosystem can support Julia. We just kind of have to hash out what that looks like.
Yeah. Yeah, right now it's like because of some changes in how like Julia does a couple of things that, it's like relatively fancily change the way how like some of the Clang dev bits work. Making it sort of, you can't really have Julia and like Numba coexisting in the same conda environment. They fight. pretty badly, and both lose, I think. Cool.
So yeah, if there isn't one already, feel free to open an issue on our GitHub. So our kind of infrastructure-wide place for issues is the github.io repo, which I will put in the chat. We should totally, if someone has the will, we certainly can help out.
Cool.
Right. What about using custom channels? Is that okay? For example, we have SciPy that all the SciPy related packages copied over from conda-forge, but this way we can better stick to use defaults for dependencies, etc., without pulling in full conda-forge. Also, I suspect the setup is faster, but that may have changed recently. So I can't guarantee 100% ABI compatibility with defaults. I might need more context for this. Do you mean that there's an independent SciPy channel, or you want to use SciPy channel in the conda-forge building? I'm not perfectly clear on that.
Yeah, in general, the way the channels are set up is like fairly hierarchical. So like conda-forge pulls a very tiny amount of stuff from defaults, and then conda-forge gets built, and then bioconda actually gets built on top of conda-forge.
Hello.
Hello.
How are things going?
Yeah, I might have missed when you started to answer my question, but don't really have anything to add to it.
So it's like it's more like, what do you want the state of the world to be? Like, what is your general pain point in your setup right now?
General pain point used to be that when you install something, unrelated packages got pulled from conda-forge, and then we didn't have any. Maybe conda lock will save that, and we didn't really have any control over those, and that's why we kind of stick to using default and telling our users to install Anaconda and then install the astronomy related packages from the SciPy channel. And then that's kind of solved. And if they wander to full conda-forge, that was their issue. So it was basically to remove our support needs.
Fair enough.
And it's still a mixture, and defaults is getting the recipes from you, but they're using different compilers. So
they're fairly close these days.
Yeah. So it kind of worked. I'm just not sure whether it's still a good setup to have the separate channel or not.
So it can be. There are several communities that do operate that way. Depending on the degree of binary interoperability you need with other things, it may be a good idea to have, like, particularly for a lot of the sort of astronomy stuff, having those things also exist on conda-forge and like basically in a way, and have them live in a way that mostly like self-updates, so that like maintenance of those packages is relatively light on your side. But yeah, it's like there's no obvious winning there.
Okay, thanks.
It's like ABIs are hard. It's unfortunately the simple sad answer.
I will say that it's a lot easier to inherit your ABI from either defaults or conda-forge than to try to get conda-forge to inherit your ABI. We have a lot of issues where bringing packages that are packaged externally to us into conda-forge is very difficult because we can't guarantee compatibility.
We are packaging on conda-forge, and that's fine, but SciPy is also in default. So
yeah, sure.
And we don't really depend on many complicated things, only NumPy.
Yeah. Your issues are likely a lot more on a lot of your downstream packages that use SciPy, right?
Yeah.
Right. And some of those don't necessarily exist in the conda-forge ecosystem.
Right.
So, like, ideally, it's like we're welcome to take them and build them as well. Turns out we build lots of things, so like it's fine. But yeah, it's like a lot of it is like conda-lock is probably going to help you at least have a way of reproducibly saying, it's like, I do a thing, what the hell's happening?
Yeah. Okay, thank you.
Cool.
Are there any plans for Conda and Momma to merge at some point in the future? Yeah, I think that's more of a question for the Conda and Momma folks. So I think Wolf is answering this in the comments, actually.
Yeah. Yeah, I think there's definitely work on those things, and as Momma is capable of basically passing more of the Conda test suite, something like that may come up again. Right now, like, you can kind of use whichever one you prefer.
And talking with Sylvain this morning for me, late last night for some of you, I think that Momma is also trying to go slightly further than conda-forge than Conda in some area. Like in particular, they're thinking about also other thoughts, being a package manager for a source file, like basically like when you want to pull the source to compile, which Conda does not.
Yeah.
So maybe not merging, but having some of the speed of Momma into Conda might be one thing, but it's not probably going to be Momma is going to merge into Conda itself.
Okay. What is the recommended way for locking, exporting an environment for the sake of scientific reproducibility of a publicly released data product? I've encountered cases of being unable to reinstall an environment a year later as a result of Conda having decided the environment now contains conflicts or a particular build was removed as a result of deficiency found later. All right, this is a Marius question.
Yeah. So like I've mentioned Conda lock a couple of times. That is definitely a way that you can use to solve this. Essentially, what conda lock does is you run the solve once, and then you store the result of that solve, and you keep it safe forever. And there's a way to install packages using Conda that basically doesn't invoke the solver. It basically just says, trust me, I know what I'm doing. And then you will get exactly that set of packages. And because you don't run through the solver, your environment will get reproduced 100% exactly. But you will obviously inherit all the deficiencies of that environment if things were fixed off or pulled after the fact, right? But like, if that worked for you, it'll likely still continue working. So that definitely helps a lot with the reproducibility. And the lock files, like, it does not save copies of packages. What it really does is it stores a simple list of like the URLs of all the packages. And then there's other tools like conda-pack. You can build Docker containers that you do a conda install into and like push that to a Docker registry. Both like conda-pack and the Docker approach will produce relatively fat artifacts. So really big ones if you need to like distribute to a system that is like, say like air-gapped or something like that. Those are super handy. But if you just want a very small set of like a text file method of this, then like conda lock may be sufficient. Like I personally use it internally for doing for managing like environments for lots of sort of healthcare data that have like regulatory FDA things associated with them, and it should be fine.
So one thing I'd want to add to that, and also to answer Michael's questions about can versions of conda-pack disappear from conda-forge. So conda-forge has a pretty hard policy where we do not delete packages. full stop. We may mark packages as broken. So for instance, if the compilation of a compiled package is genuinely incorrect, wrong flags, or it was missing something, that package is considered broken, and that is moved off of the main conda-forge label. So it's no longer accessible via a standard solve. However, the tarball and all of its binary goodness is still available on the web. So things like conda-lock will be able to still find it. Similarly, we can also do what's called repo data patches, where we actually, if the requirements were wrong, for instance, we can tweak the metadata, in this case requirements, to try to fix the solve. But no, we don't get rid of packages almost ever. I think the number of times that we've genuinely removed a package have been incredibly small.
Yeah.
All right. How is the best way to make a newly minted PyPI package available to Anaconda users? So there's currently, I think, there's three main ways. All of them use staged recipes. So conda-forge has a GitHub repo called staged recipes, where you can put up a pull request that adds the needed metadata so we can go and make the feedstock and associated package. The hardest way to do this, but the most general way, is to do this by hand. So for instance, if you have something that doesn't have a skeleton, you have to do it by hand. Java packages, I think, are one thing that don't have skeletons.
Right.
If your package is on PyPI, you actually have two options. If you're on CRAN, you have one option. So there's conda skeleton, which is available for both PyPI and CRAN. And this will go through and try to use those packaging services metadata to go and produce all the needed metadata for which are required to produce the conda package. And if it's on PyPI, you can use something called Grayskull, which is spelt with an A, which I constantly mess up.
It's the correct way to spell gray, remember.
And that's a fairly new package. And that does potentially an even nicer job at producing the metadata needed for packaging. And let me drop stage recipes into the chat. And so once you put in this pull request, your pull request is reviewed by the stage recipes team, at which point they either merge it or request any changes. So nice. Grayskull sorry, let me just finish that thought and then I'll get to Tom. And then, so once it's merged, your package will be minted. Grayskull is an offshoot of Skeletor. It doesn't use the same tooling as Skeletor. So Skeletor actually uses the depth finder AST walker, which I don't believe Grayskull uses. But they're very much in the similar vein of automatically producing conda packages, or feedstocks at least. All right. With 3.9 coming soon, what are your plans on continuing support for 3.6, 3.7, and 3.8? So this is for Python. I think we have kind of coalesced around the NumPy Python support scheme. So we're currently rolling out 3.8, which is effectively done. The only thing that's really missing is, sure, let's go with NEP29. I don't remember the number of it. The 3.8 is pretty much done. It's just waiting mostly on some really weird corner cases.
But practically speaking, everything you care about is there.
Yeah, except conda build, because leaf. Once that's formally rolled into conda-forge, so we will formally support that on all things, we will probably deprecate 36. And once 39 comes out, we'll probably start moving. Once 39 comes out, is migrated to and merged, we'll move 37 off. So usually we're doing 2, I think. But we will follow NEP29 pretty closely.
It's like NEP29 is like a good enough model. And so a large amount of the reason why we currently have a slightly smaller set of Pythons than Nep29 has. Is historically we had we didn't have enough CI capacity to build all the Pythons. We have now, so it's fine. In general, we can likely, we can pretty easily support the full set of Pythons that Nep29 dictates, especially because with the addition of the PyPI of the SciPy stack, we've actually added some Pythons as well.
Actually, I'm looking at NEP29 now, and actually we've got more support than NEP29 recommends.
Nice.
It is past June 23rd, and we still support 3.6.
Yeah. Cool.
All right. What can we do to help conda-forge in packaging? Put in more packages. We always love to see new packages.
Yeah.
If you're particularly interested in getting involved in the infrastructure, you should definitely let us know either via Gitter or on issues. I help maintain and run the AutoTick bot service for conda-forge, and we've got tons and tons of issues there, and we're happy to work with you to address some of those issues. We can act as kind of reservoirs of institutional knowledge and provide context. We are actively mentoring people who want to work on these projects. So if you want to be mentored as part of that, that's great. We're currently working as part of Google Summer Code. So yeah, please come on down and let us know. Also, please give us pain points. For a lot of us, it's especially those of us on core who are very familiar with Conda and conda-forge and all of its ins and outs and have very much bought into conda-forge. Sometimes quite literally, as we have bought merchandise. We want to know about issues that are hitting people who aren't maybe as well ingrained in the conda-forge ecosystem. So we really value those issues.
As an upstream maintainer of some packages, is there anything I can do, like PyProject.toml or something like that, that would make packaging in the long term way better? Like, for example, one of the last things I did with IPython was to do a reproducible build. Like, I can go from the source to the tar.gz, and I know it's going to be purely reproducible, and you can rerun this process and get the same artifact. Would that help conda-forge? Would that help to make builds faster? Like, if, for example, you realize that on many Python versions, the build artifacts are exactly identical, can that make conda faster and smarter to solve?
So we actually have some metadata for that. If it truly is the same, so you could mark them as no arch. I think actually the number one issue for this that we have run into time and time again is please put license files into your upstream code and any source that you distribute. The number of times we have run into issues where something has been GPL'd or BSD'd or Apache'd and no license file could be found anywhere. It drives us bonkers.
Yeah, honestly, that's like the best thing you can do. Moving to something like PyProject.toml and having nicer builds will definitely help, but it'll likely help more on the side of tools like Grayskull will be better at finding your dependencies and matching them up, right? So, and as we start moving towards having our automated sort of PR systems use those tools more aggressively, you will get that your sort of semi-auto maintained conda-forge version of your feedstock will likely match your repo a little bit better. So by providing better sort of package metadata to PyPI, you will eventually help us. Not necessarily right now, but soonish.
Yes.
Cool.
All right. Could there be a way to provide a smaller repo data.json for a subset of conda-forge? For example, for a specific package or collection of packages to provide people with faster resolve times for smaller environments? Marius, would you like to take this one?
So we ran an experiment. So there's So there's a thing that I built a while back called Conda Meta Channel, which sort of like did this in a relatively dynamic way. That worked okay, but it has like a fair amount of general problems with how it works. Ultimately, the thing that like having some degree of the general inherent support for how that works in Conda exists right now. So if you run a modern version of Conda, which hopefully you do, then you'll notice that when you install, you will typically be installing from the current repo data.json, and it'll be pretty fast, right? So like that drastically helps things. But the problem is like splitting out that ecosystem to different sort of subdir files, or different of these sort of like, it's like resolution of current repo data.json or repo data.json gets a little tricky. And since most of that exists like fairly upstream on like the Anaconda side, there's not that much that conda-forge itself can really do about that. So like, I think having these sort of smaller ecosystems makes sense. The problem is like having a way for users to specify what their priority and preferences are for in which order you want to fetch from those, right? But like we have a lot of like, I think as our ecosystems get larger, that's definitely a thing. Like we did find that if you use like Conda Meta Channel to do like some solution, you do get like massively increased like solve times, because it turns out solving for a handful of packages is super easy, even without resorting to using Momma, right? We turned it off because it was mostly just like running that infrastructure started becoming like, we didn't see a lot of people really use it that much, and like running that infrastructure started becoming a little expensive.
Yeah. Does Conda, I presume conda-forge, have any plans to deal with typo squatting and name squatting issues like SciPy does? So the SciPy and conda-forge models for how to like make packages are very fundamentally different in the way that Conda has a lot of review, or conda-forge has a lot of review involved of these packages. So I think it would be fairly straightforward to find out that like you have a typo squatting issue with NumPy because someone actually reads through that thing. If it comes to the point that we end up with a lot of these, we might be able to build tooling on top of our linter to look for these and do like some sort of Levenstein distance between your package and all the other packages. But currently we haven't had those kind of issues. Note that was not an invitation to start giving us those issues, please. Our stage recipes maintainers are taxed as is. As per name squatting, I think we've had mostly raised an issue on the feedstock, and we'll deal with it. conda-forge core usually gets involved when archiving a feedstock, such that other feedstocks could take over. But that is a very rare occurrence. Can versions of conda-forge packages disappear from conda-forge? Nope. I think we addressed that one.
Yeah.
Do y'all have the data on recursive health of conda-forge packages, especially with respect to security issues? Thinking about how to avoid issues that NPM has. It's like manual intervention is going to become cumbersome soon. So I don't think currently we have security checks in that way. It's not like we have a bot that runs through all of our artifacts.
Yeah, we don't have anything that like automatically runs Black Duck or like insert your security scanner of choice on the artifacts.
I think that would be a great piece of infrastructure, though.
Yeah. It would be nice.
Yeah. So if you're interested in,
like, if you care a lot about those things, like Anaconda does have as part of their product, they do a lot of those checks for like the Anaconda distribution, like, you know, it's like give you things. So if you have enterprise dollars to spend, those are not necessarily bad ideas.
Yep. Are there similar automated tools to add CMake projects to conda-forge? Not to my knowledge, but someone could go write a conda skeleton for CMake projects, I guess.
Maybe. I think we have a very large amount of existing CMake projects that do get built on conda-forge, so there's likely enough bits and pieces that somebody could go look at for finding some common patterns. I think it also depends on the degree to how good CMake packages use some of their things where they determine dependencies. A lot of that stuff varies pretty heavily amongst repositories. So I question how far you can get to a 70% solution, but a 70% solution is a hell of a lot better than nothing, right? So I think that should help.
I don't have a chance to use conda and always use pip. What is a good point of using conda? Well, there's an actual solver.
Yeah.
It'll give you the correct things, which is potentially a slightly trolly answer. So, I don't know. I think historically conda has done a better job of installing binaries in a way that is compatible, especially given how wheels work. Additionally, pip installs Python. And it doesn't install other things, so good luck doing pip install Rust. That is very much a possible thing to do with conda. Okay, sorry. I should explain what the solver does. And Jonathan can stop me when I go off the rails here. So the basic idea of the solver is that when you have all your dependencies, they have some relationship with each other where they might not all be mutually compatible. And the solver builds a giant graph and tries to handle which versions of all of the packages that you want are mutually compatible in a way that when you produce an environment, they'll all play nice with one another. If for places where this doesn't work, for instance, is if you install a version of NumPy with the wrong version of OpenBLOS, you will get very weird looking errors that are essentially non-debuggable. So the solver addresses this issue. But I think the biggest strength especially of conda-forge at the moment, is that we package all sorts of languages. We've got Python, C, R, Rust. I think we still have an OCaml build somewhere.
Yeah.
And
a bunch of Go stuff.
We have Ghost. We have a whole bunch of Go stuff. And the fact that you can conda will smartly mix and match your dependencies, as opposed to having a wheel that's pretty much has to have all of your dependencies baked in.
So yeah, so wheels have definitely helped the pip ecosystem move forward massively, but you can't pip install Python. That doesn't even make sense. So conda sits at a different level of package manager than pip does. So they can be used complementary, provided you're careful. The general ways how you use them carefully is there's a blog post linked earlier in the chat, but just for the video posterity, in general, conda create your environment with the things you care about, then pip install the things you care about, and never touch that environment ever again. And if you need to do changes to it, throw it away and create a new one with roughly the same specifications, and then you'll probably be fine. No real guarantees here, but in general, that's been shown to work well. Where you head into troubles when mixing, is when you do, I conda install a thing, and then I pip install a thing, and then I conda install a thing, and then I pip install a thing, and now your environment's broken.
Right. Maybe I missed it, but can you discuss the current situation with the AD defaults versus conda-forge build stack differences and inability to mix the two channels safely? Is interoperability still a design goal, or are things moving towards enforcing not mixing the two within an environment? Yeah, I think there's certainly an ordering in which you should kind of engage the different channels. And let me be very precise here. Like, although we can't guarantee 100% ABI compatibility because ABIs are hard, like, we're really good. Like, it's just not 100%. It's just really close. So 9 times out of 10, you're probably fine. If you're not fine, there are ways to get around that.
Yeah, it's like generally, it's like if you're in one of these really weird cases, then like probably ask in the Gator chat. People hang out; they can generally help.
Yeah. What do you envision the role of Docker and Conda in the near future? What do you think using Docker replaces Conda? Well, Docker still has to get its packages from somewhere, right?
Like they work very well together, right? So in fact, like there's quite a few tools that like from a specification of like Conda packages builds you a nice Docker container with those things in, because Docker containers are relatively nice distributable artifacts, right? The two are complementary tools, so we do not. It's like, in fact, like pretty like essentially almost all of the conda-forge packages are built inside a Docker container which contains conda, right? So they work together extremely well.
Yeah. And then how about Docker plus pip versus conda? I think that's very much determined by your use case, right? If your use case is extremely reliable, environments, or, my software in a box, then Docker might be a better way to go. If you need a more dynamic environment where you'd like to plug things in and pull things out, and you want to try out the newest version of something, then maybe rebuilding a Docker container from scratch might not be the easiest thing for you.
But yeah, I think it's like they exist in slightly different spaces. Like, cool.
Is the best way to request an update to a conda-forge package that you yourself don't maintain or contribute to raise an issue on the package feedback repo? If there's more recent SciPy release and the conda version behind. Okay, so one, the audit bot usually addresses this and produces PRs for most of those things. If it doesn't, you should totally let us know at the audit bot. However, those are not automatically merged on most feedstocks as of now. You should maintain that. Like the real answer here is like, yes, you can ask the maintainers to merge stuff for you and you can help out, and you should totally go and try to fix the PRs if they're not working properly. But you should seriously consider becoming a maintainer, especially if that software is kind of mission critical to you.
Yeah,
conda-forge is fundamentally a volunteer federated system.
Yeah, and like particularly in those places where like a lot of these times like PRs get made to, there's a lot of sort of like the core of conda-forge is very healthy, but there's some of the the outer edge of the outer edges of the gardens have a couple of it's like unruly weeds growing and like that are just like a little bit unkempt. We're doing things to make this better, but some of it is just time, right? It's like help the general sort of additional load of helping out by being a maintainer on a package is typically extremely low. So, and you don't need to necessarily understand how all of conda-forge works. You don't need to know the understandings of the internal knowledge of like the tooling and all that. Like we have systems in place to make that kind of work. So it's mostly just like it helps.
Yeah, and especially now with auto merge kind of available, now mostly the humans act as troubleshooters for those who maintain packages more often than not.
Yeah.
And
Like-
for packages that don't move their dependencies too often, that's usually a safe option.
Yeah. Cool.
Cool. We got through all the questions. Woo! I didn't have
Congrats.
too much fast New Yorker speaking.
That was great. I suggest that if someone is new and want to just say hi, they just raise their hand, and we will be happy to say them welcome to the SciPy community and in BOFs, and thank you for coming to BOFs. And otherwise, I personally hope that I will be able to see all of you in person next year, because SciPy without being in person is not the same, but still
Not
really
quite the
great.
same.
And I'm not sure. Apparently, when it's o'clock, we're probably going to be kicked out. So thank you very much. Feel free to send us feedback. It's the first time that we do BOFs online this way, and we've done our best to try to invite people. It's easier when you go through question, but because of the 15-second delay, it's sometimes hard to pull someone in, because otherwise they basically miss the beginning of the conversation because they get pulled in before they have heard the first answer from our speaker.
Yeah.
And so see you online. Don't forget to come tomorrow. There are more BOFs, and at the sprint at the end of the conference.
Cool.
And we can slowly keep discussing until we get kicked out. It was nice seeing you all.
Sorry about all the links that forces people to read all the things.
Yes.
It's fine. It's perfect. I didn't have time to focus on everything because I was clicking behind the scene. But thanks for everybody who also answered in the chat. That was relatively great.
Yeah.
All right. Bye, everyone.
Cheers.
Okay, let's end the broadcast. Bye.